Let's start. Sorry, I just starting a little late there, but let's start chapter 4, which is a overview of the 10 solutions for bending the curve. So we set up some preliminary backgrounds of climate change, some social issues, climate change and health, and we will jump now into starting to look at the solutions and see how they are organized. All this came out of a discussion of the faculty of the University of California system after Janet Napolitano, who became the president of the system, uh, provided a mandate saying let's go carbon neutral by 2025. So here when we say solutions, they are all mitigation solutions. So remember we talked about mitigation and adaptation. If you want to go carbon neutral, you don't always have to separate mitigation and adaptation, but here the focus will be on mitigation. What are we mitigating? Obviously starting with the amount of carbon dioxide specifically, that remains in the atmosphere. This science of carbon cycle keeps getting better. There is some uncertainties, some missing sinks, as we would say. So if you look at the results from, this is from 2008, I think 2007 here. The previous consensus on how much carbon was being taken up by the northern hemisphere land. So you can see these are negative numbers in terms of billions of tons of carbon. As I said before, carbon and carbon dioxide have a multiplication factor of 3.7. You can make sure exactly what it is, but the new result, new update, says that actually that number may be quite a bit smaller. Okay, and the tropical lands, which are net emitter of carbon to the atmosphere, was supposed to be emitting about 2 billion tons of carbon per year, but now the new result says it's much lower. So these adjustments, it's not as easy as measuring CO2 in the atmosphere itself, because that, as we said, is a long-living inert gas that gets well mixed. So if you measure it in one or two spots in each hemisphere, you get a good estimate of the global mean. Whereas the sources and sinks are very local, very regional, and you need lots of data to estimate these. Nonetheless, where does all the carbon dioxide go? Right now we are up to about 40 to 50 billion tons of CO2 per year, as we will see later on. 30% is estimated to go into land cover, and 30% is going into the ocean. There is a chopper coming by which is going to make a lot of noise. And about 40% stays in the atmosphere. So what we measure is about 40% of the total. How do we know that? We have numbers like this. The fossil fuels are a very valuable commodity. So there is a very accurate tracking of the production of coal, gas, oil, and so on. And you have good estimate of how much carbon they are emitting. So there is the CO2 flux in gigaton carbon per year, starting in 1900, coming up to 2016 or so. You can find the latest one on Google if you wish. But the point is, there is also some emission from the land use change. So this is the deforestation, urbanization, conversion to agricultural land, and so on. And so those are the positive numbers, and the negative numbers are the ocean sink that we talked about 30%, the land sink. There is often what is called a missing sink, so we don't match the total emissions to the total absorbed compared to what remains in the atmosphere. Okay, because when we say land sink, it is going into wetlands, in salt marshes, taken up by vegetation. There is something called carbon fertilization. As you increase carbon dioxide in the atmosphere, photosynthesis can accelerate. Remember, photosynthesis needs CO2 and water. So if you increase CO2, they can photosynthesize more per unit of solar radiation they need for energizing the photosynthetic reaction. CO2 plus H2O gives you CH2O, the basic molecule of carbohydrate, right? So this is how we do that, but as I said, the distribution is very local, whether it's on land or in the ocean, unlike the atmosphere where it gets well mixed. Why do we need climate mitigation at all? Well, in case you're already not convinced, there are quantifiable benefits from large-scale mitigation. This is an estimate from this Climate and Clean Air Coalition, which puts out incredibly good numbers and information. From large-scale mitigation by 2030, we are going to avoid some warming, so we are going to reduce the sea level rise by 20% by the time we reach 2050. We are going to reduce glacier melts and snow and ice melt. We're going to reduce the sea level rise. Why did it come twice here? Okay. Health, the number of people that are going to benefit is going to be at least 2.4 million by 2030. Avoided premature deaths annually from outdoor air pollution. This is annual deaths per year. Annual deaths per year. Annual deaths, so it's not a small number. Reduced air pollution, world's largest environmental health risk in terms of all the diseases that we talked about. The labor loss, productivity loss, and so on. Okay, crops is going to be 52 million tons of avoided crop losses from 4 major staples per year, like rice, wheat, corn, and I think soybean, maybe. Right? We can look that up. So these are the co-benefits. The co-benefits are always important to track for climate action, because climate action costs money, and economists want to know the return on investment. Especially when you worry about the future, they talk about the dollar invested today and what it will be worth in 10 years or next year or in a week. That's called a discount rate. A dollar that's worth today 100 cents would be worth only, let's say, 90 cents in a year or less in the future. So they worry about these things. So we always have to track the benefits, the return on investment. But again, the problem there is to count for externalities. How do you count for the impacts of a better life, a healthier life? How do you account for children being able to play safely outside without worrying about pollution and so on? So accounting for all the co-benefits is not always easy, but the big ticket items like number of deaths saved from air pollution are easily estimated. Okay, this is important to remember. So in this context, we'll look at the 10 solutions proposed in this book. Obviously, it evolved in the context of University of California system, but as a course, we have to make it more specific to any particular place. Like now I'm sitting in India. What would be the 10 solutions for India? They're almost the same, but the way you get there, the cost and the benefits can be very different.